Welcome to lecture series on design and analysis of algorithm. So this lecture is a continuation of previous lecture where we have discussed about dynamic programming approach. We have seen what is greedy approach and what are the problems that can be solved using dynamic programming and greedy approach. We have also seen what is a spanning tree and what is the need for a spanning tree and what is minimum spanning tree also we have seen, and we have seen the major difference between a spanning tree and a minimum spanning tree. So let me give a quick recap of the difference between a spanning tree and minimum spanning tree. So these are the topics we have seen in the previous lecture. So the main difference between a spanning tree and a minimum spanning tree is that a spanning tree is a subgraph of a given graph that contain all the vertices of the graph which are connected with minimum number of edges. However, minimum spanning tree is also a spanning tree whose edges sum to the minimum weight. So the spanning tree with minimum cost is called as minimum spanning tree. So for constructing a minimum spanning tree, we have two algorithms. One is Prim's algorithm and other one is a Kruskal algorithm. So these two algorithms work in different way. However, the outcome is the same. That is, for a given graph, even if you apply Prim's algorithm or if you apply Kruskal algorithm, the final minimum spanning tree which is being constructed will be the same. So irrespective of the input you are giving, the outcome, irrespective of the input and the algorithm that you are using, the outcome is the same. So first, let me explain about Kruskal algorithm, which is easiest of all. So initially, this algorithm begins by choosing a random vertex and adding it to the minimum spanning tree. That is, so the steps are like, initially you will identify the edges along with its cost. So you will start including the edges that is having the minimum weight. You will start including the edges in the order of choosing an edge with the minimum cost. So as you include, you will make sure that including a particular edge will not form any cycle. If in case it forms a cycle, you will discard that edge or you will avoid that edge. The reason why you are discarding that edge is because, as we have seen in the definition of spanning tree, a spanning tree does not have any cycles. So that is the reason why you will discard the edges when it forms a cycle. So you will repeat this process until all the edges are apart. Until all, I will not say like until all the edges, you will repeat this process until all the vertices are part of minimum spanning tree. So the final edge cost, sum of edge cost will be the cost of minimum spanning tree. So this is the working of Kruskal algorithm. So when it comes to Prim's algorithm, its working is almost similar to Dijkstra's algorithm, which we have seen in identifying the shortest path. So first it sorts the it begins by choosing a random vertex and it adds to the minimum spanning tree. Then it continues to look for the smallest edge weight of its connected vertices. For example, let me, when you will understand this even better when we discuss with an example. So this procedure again, it repeats until all the vertices are becomes a part of minimum spanning tree. So first let me look at explain with an example. Look at this particular graph. So when we want to apply Kruskal algorithm, how does Kruskal algorithm works? As I said earlier, you will choose the edge with the minimum cost first. So here the edge E to D has the minimum cost, so that you will include. So the next edge FE has minimum cost. So including this will not form a cycle, so you will include that edge as well. So next, the edge AF has minimum cost. Again, including that will not form a cycle, so you will include that edge also. So next, the edge AE has minimum cost, sorry, FB has minimum cost 4. Again, including that does not form a cycle, so you will include that particular edge. Next, the edge BE has minimum cost 5. However, including that edge forms a cycle BFE, so you will discard that particular edge. Similarly, when you include the edge AB, again it forms a cycle A, B, and F, so you will discard that edge as well. And likewise, the edges AE, CE, and CD forms a cycle, so those edges are discarded. So now see, with this, with the edges that I have included, it is made sure that all the vertices are connected, right? So here we have 6 vertices in the given graph. In the spanning tree that I have constructed, minimum spanning tree that we have constructed using Kruskal algorithm, also we have 6 vertices and all the 6 vertices are connected. So this is how a Kruskal algorithm works, and cost of this minimum spanning tree is 7 is 2, 9, 9 plus 9, 18. So the cost of this minimum spanning tree is 18. So this is how the Kruskal algorithm works in finding the minimum spanning tree. So I'll give a quick recall of all the steps. So initially you have to solve the edge, you have to sort all the edges in non-decreasing order of weight. You have to pick this edge with the smallest cost. You have to check if it forms a cycle with the spanning tree formed earlier. If the cycle is not formed, you will include the edge. If in case cycle is formed, the edge is discarded. This step is included until there are v minus 1 edges in the spanning tree and or until all the vertices are connected. So thanks for watching. In the next video, I'll explain about how Prim's algorithm is used for constructing a minimum spanning tree. So Prim's algorithm works in entirely different way when compared to the Kruskal algorithm. So before we wind up, let me have a quick assessment to make sure you have understood this topic. So first question is, which of the following is false in case of spanning tree of graph G? So the first is it is tree that spans G. Second is it is a subgraph. Third is it includes every vertex. The last one is it can either be cyclic or acyclic. Of all these 4 points, first 3 are correct. And as we have seen earlier, spanning tree definitely is an acyclic graph. So fourth point is false. So next question we will discuss when we are talking about, when we see about Prim's algorithm. So thanks for watching. Continue watching the lecture series to understand Prim's algorithm. Thank you.